In this video, we're going to look at how to write equations of parallel lines. Just a review, you need to remember that the equation of a straight line comes in the form y equals mx plus c, where m is the gradient, which describes the steepness of the line, and c is the y-intercept, which is the point where the line crosses the y-axis. So in my example, I have a graph of a straight line, and I can actually work out the equation of this line. So I need to work out the gradient first, so I can work out the change in y, because remember that to find the gradient you divide change in y by change in x, and the change in y is 2, then the change in x is 1, so that means the gradient is 2. And then I need to find the y-intercept, so this is the point where the line crosses the y-axis, which is positive 2. So I can put those together, and I know that the equation of this line will be y equals 2x plus 2. So in this example, I need to find the gradient. So my change in y is 1, change in x is 2. That gives me the gradient of a half, because 1 divided by 2. And then the y-intercept, which is where the line crosses the y-axis, right here, and that is positive 3. So I put these together and get the equation, which is y equals a half x plus 3. In this example, I notice that the line is going down, so I expect to have a negative gradient. So the change in y is negative 3, and change in x is 1. That means that the gradient is minus 3. And then the y-intercept is right here. This is where the line crosses the y-axis, and that is positive 4. So I put this together and I get the equation, which is y equals minus 3x plus 4. Please have a look at those three lines and see if you can find the equation of every single one of them. So pause the video and have a go. Once you're ready, press play. And these are the correct answers. Now what I would like you to do is I would like you to try and work out the equation of line A, B and C. We know that the equation of the green line is y equals 2x plus 3. So think about it and see if you can find out the equation of line A, B and C. So please pause the video and have a go. So the equations that you should get are as follows. For line A, it should be y equals 2x minus 1. For line B, y equals 2x minus 6. And for line C, y equals 2x plus 8. Now what you should notice is that all of those lines have the same gradient. So all the black lines and the green line as well. Okay, and the reason why the gradients are the same, because those lines are parallel. Okay, and this is the fact that you need to remember, that parallel lines will have the same gradient. It's quite logical when you think about it, because the steepness of those lines are the same, and the gradient describes steepness. So we can use this fact in lots of different problems. But first I would like you to think about an equation of any line that is parallel to those given ones here. We can come up with lots of examples, because we don't know exactly where, any other points where those lines need to go. So I don't have a y-intercept given of the line that I need to write down an equation for. So it could be any line which is parallel to the ones that are given here. So when I look at question A, first of all I need to identify the gradient here, and the gradient is 3. So that means that the equation of the line that is parallel to this one has to have the same gradient. So I need to have y equals 3x. And in fact, this line is already parallel to y equals 3x minus 3, because I have the same gradient. So that could be one example. It could be y equals 3x, for example, plus 1. So it doesn't really matter what the y-intercept is, as long as the gradient is the same. So for part B, the gradient is minus 2. So y equals minus 2x, that will be an equation of a line that is parallel to line B. Okay, it could be y equals minus 2x plus 4. Okay, it could be plus 10, it could be minus 5. It doesn't really matter as long as the gradient is the same. The next question, okay, it's a little bit trickier, okay, because remember that for us to be able to identify the gradient from the equation, I need to have y equals mx plus c. Right now, I've got 3y. So I need to do first, I need to divide the whole equation by 3. Okay, so when I divide 3y by 3, I'll get only 1y. Okay, and this is what we're trying to achieve. But you need to remember to divide the whole equation. So then 6x divided by 3 will be 2x, and then negative 12 divided by 3 will be negative 4. And now that the equation is in the form y equals mx plus c, I can see that the gradient is 2. So y equals 2x would be the line that is parallel to this one. It could be y equals 2x minus 5, for example. That will be also parallel to the line in question C, because the gradient is 2 for all of those lines. Again, in question D, we need to manipulate this equation first for us to be able to identify the gradient easily. So right now, I've got x term on the left side as well. I need to get rid of it, okay, because that needs to be on the right side. So the terms y and x need to be on different sides. So I need to get rid of 4x, so I need to take it away from both sides. Okay, so now I have 2y equals minus 4x and then plus 6. Also remember that I need to have y equals mx plus c and not 2y. So now I need to divide the whole equation by 2. So that's y equals minus 2x plus 3. And now I can see that the gradient is minus 2. So I know that y equals minus 2x will be parallel to this line. It could be y equals minus 2x plus 6. That would also be parallel to line in question D. I would like you to have a go with these questions. The questions in the red box are slightly easier. We know that each pair is a pair of parallel lines, so you just need to identify the gradient of them, and sometimes it might be easy to work out what the gradient is looking at one line or one equation, and sometimes the other one is in a slightly harder form, but because they're come in a pair, it should be quite easy. Now they do get a little bit harder as you go, and now in the green box you need to write an equation of a parallel line to each of those lines. So this is something that I've just done for you, but you need to remember that the equation needs to be in the form y equals mx plus c. Okay, so pause the video and have a go. Okay, so for example, the first pair, the gradient is 5. Okay, so in the first example, the gradient is 5. So you can see that's quite straightforward. It's right here and right here. Okay, for the next one, the gradient is minus 3, and it's easier to spot that gradient from this example here. And remember that the gradient is the number in front of x, and it's not the first number, not the first value after equals. Okay, it's more difficult to see it from the other equation. You have to rearrange it first, but because we know that they are parallel, so we know that the gradient will be the same for both of them. And in the third example, it's probably easier to work out the gradient from the second equation, because I know that I have to divide both sides by 10, because I've got 10y and I need to have only 1y. Okay, so I have to divide both sides by 10, and that will give me minus 2/10 or minus 0.2. Okay, I'll have to rearrange the first one to get the gradient, so it's much easier to use the second one to read the gradient. Now for the second part of the questions, For the first one, quite straightforward. Okay, we know that the gradient here is 2, so I could write down an equation of a line where the gradient is 2. So it could be y equals 2x plus 1, it could be y equals 2x plus 3, it could be y equals 2x minus 10, as long as the gradient is 2. For the next one, you need to rearrange this equation first for you to identify the gradient. Okay, and when you rearrange this equation, you see that the gradient is minus 2. Okay, so then any equation with the gradient equal to minus 2 will be fine. And for the last one, again, you have to rearrange this equation, and you'll see that the gradient is minus 0.1. So any equation with the same gradient will be fine here. Now, you may see a question like this as well in an exam, okay? This is a slightly easier version, okay? But we're going to explain how to do this. So I know that I have a line, I know the equation, that's y equals half x plus 5, and I need to write an equation of the line that's parallel to this, but it also goes through a certain point, and I have the coordinates of that point, okay? So I need to remember that the line needs to have the same gradient because the lines are parallel. So I know for sure that will be y equals a half x, but then I need to have a y-intercept, and I'm told that the line needs to go through 0, 2. Now, because the value of x is 0, this is actually y-intercept. Okay, so when you spot that, because if I was to plot this point, okay, 0 is here and let's say 2 is here. So this point, because the value of x is 0, that point is on the y-axis. So this is the y-intercept. So I know straight away that the equation here would be a half x plus 2. Okay, now I'm also going to show you another method just in case you don't realize that this is the y-intercept, or if the coordinates are actually for a point that is not on the y-axis. So you need to remember that this is the x-coordinate of the point and this is the y-coordinate of the point. And because this point is on that line, I can put the value of x and y into my equation. Okay, so the value of y is 2. And then the value of x is 0. Okay, now a half times 0 is 0, so that means the value of c is 2, which is something that we already know. I just wanted to show you that you can calculate it by substitution as well. So I would like you to have a go with this question now. So please press pause and have a go. Okay. So again, because the lines are parallel, so I know I need to have y equals minus x and then plus c. And just like with the previous one, I spot that this is actually the y-intercept. So I know that the equation of the line that is parallel to the given line and goes through point 0 minus 4 is minus x minus 4.